Hi, this is Noah, and I'm going to be doing a little kind of analysis of how my code works. I'll be stepping through the code and explaining it, and then if I have time, I'll do a little demo. So I'll just boot up my VM. And I'll go to the advanced options and choose my development kernel from project 1. And I'll log in and get my environment ready. And open my producer consumer.c file. So starting off, obviously these four are the 4 variables. Well, these are 4 of the key variables that are passed in from the command line. So the size of the buffer, the number of producers, number of consumers, and the UID. And so that's just the user that's making the requests, or pretty much. Here, this section, this is actually passing in the command lines into the program, so it's passing everything into the program for the buffer size, the producers, consumers, etc. And then I read the helper document, and I figured that the best way to implement the buffer would definitely be a linked list. So I implemented this here. So obviously a linked list has a next node, previous node, and then for our implementation, each node will have a task that it has attached to, pretty much. The index, so the first one will be index 0, next one will be 1, etc. The ID, so the first one that we process will have an ID of 1, the next one will be 2, etc. And then each node also has a PID, so the process identifier. And so we create the head and tail, and we set those to null, and this will just help us later on when we're first creating the linked list. We'll be able to tell that the linked list isn't made yet, pretty much. This total lap seconds is for obviously the total seconds. So at the very end, when we print out it'll say how many total seconds we've been running. We have a pointer to our producer thread. We'll use this later for when we initialize the thread, and then a double pointer to our consumer threads, and again that'll be for when we initialize these threads and run them. And I have 4 semaphores, and then 2 of them are mutexes specifically. This one just gates the buffer itself, so reading and writing from our linked list buffer. This one is for this element, the total lap seconds. Just we don't want multiple threads incrementing this at once. And then a semaphore for full and empty. So the full is the producer can't write to it if it's full, obviously, and the consumer can't consume anything off of it if it's empty. So Boolean should stop, so we'll use this later when we kind of want to kill the threads, pretty much. They'll just know to stop when this is true, and then when we initialize, it'll be false. When we initialize the threads, this will be false, but when we want to kill them, it'll be true. Task counter. This is for giving us the ID. We'll just be incrementing this. Pretty much, it'll just be running throughout the entire program. So the first one is 1, 2, etc. Go down to the producer section. That makes more sense. So this is a task that we're reading in. So obviously there's a bunch of threads that we need to process, and each one has its own PID, etc. Obviously we want to ensure that the UID is the same in our program. So we wouldn't want to be able to, we wouldn't want this program to run like root level things if like the user wasn't root, just like a kind of security thing. These semaphores just handle kind of things that obviously wouldn't want to happen. If it's empty, we wouldn't want this stuff to happen. If it's should stop, if this was true, this entire thread would be kind of killed, and then we'll kind of see that later. And then this is kind of the linked list implementation, this whole section. So for this one, when we first start the program, this one will be triggered first because the head is null. So the linked list is made from scratch, and we can see that the head and the tail are the same. And then all the details are filled in, all the data is filled into the node. And then similar thing here, except we're making a new node, and then we're pretty much placing that at the end, then having the previous one point to this one as the tail. And then again, all the data is filled in. And then here we're printing out the kernel info, the producer text, just all the stuff that we need. So the produce item at the buffer index for PID, this kind of stuff. And then here we release the semaphores. And we can go back up into the consumer. Same stuff here with the semaphores. Here we're creating a temporary tail, and this is kind of starting the process that's going to be happening down here. I'll focus here. So we want to calculate the time of each process, and then as well we're adding to this total seconds elapsed with the seconds elapsed. And then here we're converting from nanoseconds to seconds, and then we get the hours, minutes, and seconds by dividing and then doing modulo, and dividing and modulo again, and we'll get the hours, minutes, and seconds. And then down here we're finishing the popping thing, not the thing, the popping operation. So the new tail next is null, because this would be the tail, and then the tail would be the new tail. And then this is if there's if the length is 1, kind of a similar thing. You can go to the initialize. So we're initializing all these semaphores. Just as you can just read it, it makes sense. I mean, it's like self-explanatory is what I mean. Should stop is false because we obviously want everything running. For this, as many tasks are coming in, we're producing as many as we can with the buffer. And then for this, the consumer, this one's different because we can have multiple threads, multi-threading for each consumer, because there's always going to be one producer. This GPL line is important because that kind of messed me up because I had to search on how to fix this. It was just like a weird error thing. The exit, the should stop is true, so when for each of these, it'll encounter the should stop and it'll be true, then it'll break and kind of kill that thread. And then as we're exiting, we're also calculating the total time for all the processes, and it's like a very similar thing, except for this we're using the total seconds. So yeah, it's pretty much it. And then I can do a quick little demo. I'll just do test case 3 for simplicity's sake. So we'll do 10, 50, 1, 1, 25. And so for this one, we're looking for 12 to be produced, and all 12 should be consumed. And then obviously you can't have one thing being produced and consumed more than one time. So let's see here, we produce the 12, and then we work backwards. We consume 12, 11, 10, etc. back to 1 on index 0, and you can see the time is pretty similar. I can't get it, like, this is like as close as it gets pretty much, so 1 minute 15 compared to 1 minute and 6 seconds. And that should be it.